Let's take a look at this problem. We got f of x is equal to x squared minus 9x plus 14. And let's go down through the different items. A, find a domain. Well, it's a polynomial, quadratic, so our domain by default is negative infinity to positive infinity. It exists everywhere. Now B says to find the X-Intercept. To find the X-Intercept, you plug 0 into the other variable, so we'll plug 0 in for y. So we got 0 is equal to x squared minus 9x plus 14. Now this one will factor. This is the PST, and it factors as x minus 2 times x minus 7. Now the zero factor property says if you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0 and x minus 7 equal to 0. So we get x equals 2 and x equals 7. Oops, try that again. X equals 2 and x equals 7 are x-intercepts. And this is our domain. Okay, C. C is to find the y-intercept. You always plug 0 into the other variable, so to find the y-intercept, you plug 0 in for x. So f of x is y. Y is equal to 0 squared minus 9 times 0 plus 14, which means we got y is equal to 14. And that's our y-intercept. Now D, vertical asymptote. Well, you only have asymptotes if you have a rational function, single fraction. We don't have that, so there's none. E is horizontal. Yeah, horizontal. Again, you don't have those unless it's a rational function. F is slant asymptote. Again, you don't have that unless you have a rational. G, intervals of increasing and decreasing. Well, we need to find our derivative. So f prime, derivative of x squared minus 9x plus 14 gives us 2x minus 9. Now we want to find our critical value. So do you set 2x minus 9 equal to 0 and solve it? And we got 2x is equal to 9. Divide both sides by 2. We got x is equal to 9/2. Now we will pick test cases. Clear over here is negative infinity. Clear over here is positive infinity. Something between negative infinity and 9/2, like 0. Something greater than 9/2, like 10. Now we want to plug those into our derivative. Our derivative is right here, 2x minus 9. So we got 2 times 0 minus 9 and 2 times 10 minus 9. 2 times 0 is 0 minus 9 is negative, so that's decreasing. 2 times 10 is 20 minus 9 is positive, so that's increasing. So this is decreasing from negative infinity to 9/2, and then it's increasing from 9/2 to positive infinity. Okay, H, minimum, maximum, extrema. Well, that's where it changes. This is going decreasing, changes to increasing, so this is going to be a min. Now we're going to have a min at x equals 9/2. So we're going to take that 9/2 and plug it back in the original function and find out what our y value is. So we got y is equal to 9/2 squared minus 9 times 9/2 plus 14. And I'm not going to work that hard. 9/2 squared, so beginning parentheses 9 divided by 2, close parentheses squared, minus 9, beginning parentheses 9 divided by 2, closing parentheses, plus 14. Enter, and then math, enter. Math, enter changes it to fraction. And we got negative 25 over 4. So our minimum is going to be at 9/2 and negative 25 over 4. I. What is I? Concavity. Well, we need our second derivative for that. So for a second derivative, we'll pick up where 2x minus 9 left off. So derivative of 2x minus 9 is 2. Now there are no critical values, because if I try to set that equal to 0, there's no x to solve for. So our interval is from negative infinity to positive infinity. I want to choose a test case in there, like x equals 0. And then we want to plug that into our second derivative. Well, here's our second derivative, 2. Well, if I plug it into here, there's no x, so it's always 2. So it's always positive, which means it's concave up. So our graph is concave up from negative infinity to positive infinity. Now, J, our points of inflection. Our points of inflection is where the concavity changes. Well, it didn't change at all, which means there are no points of inflection. And then K is our graph. So continue over here. I'm going to sketch it. Purposes of the homework, you can just go ahead and plug it in your calculator, and wherever your calculator gives you is your answer. Okay, let's see. 14. There's 14 there. Here would be 7. So then this would be 7, 14. And over here would be negative 7 and negative 14. Okay, our y-intercept is at 14, we said. So it's right there. We said that our x-intercept is 2 and 7. Here's 7. And 2, halfway would be there. I don't know, 2's maybe about right here, if I had to guess. Let's see, no asymptotes. It's decreasing to begin with and increasing, which makes sense to what we're seeing here. Decreasing and then increasing. Our minimum point is 9/2, which is 4.5 or 4.5, and negative 25 over 4, which is negative 6 1/4. So 4.5 and so 4.5, let's see, about right there, and then about right, I don't know, let's say right there. That's going to be my min. Okay, points of our concavity is concave up everywhere, so based upon that, here's my graph, coming down like this, reaches there, comes back up, and that's probably as good as I'm going to be able to freehand it. Now, if I were to graph this into the calculator, I'm going to press my y equals, press clear, and then I got x squared minus 9x plus 14, and then graph. And there you see a much better sketch than what I came up with. But anyway, you get the idea.